So first step, if we're looking at what we're going to be viewing today, so overview of existing automation for North American window manufacturing from cutting to assembly. This also applies to patio doors. This also applies to tilt and turn windows, so European style windows. Just a little difference here and there. But if you do have questions, please feel free to ask your question live. I'll do my best to answer as you're asking them. So optimization of heading times and hardware prepositioning is going to be today's subject. So first stage, obviously, cutting and fabrication. If you're looking at a smaller factory, like we have a lot in Quebec, maybe you're going to be looking at separate workstation. So on the screen here is just an example of a regular double miter saw capable of cutting 2 parts at the time, and a standalone fab center. Fab center in there, you're going to be able to do, if you're looking at sashes, you're going to be able to do all your hardware pre-location. The only thing you're not going to be able to do in one of those would be drainage if you're looking at casement sashes, but if you're looking at hung-in sliders, you're going to be able to do even up to your drainage as well. If you're looking at working with frames, you're going to be able to do, again, everything but drainage on those. There's a lot you can do when you're thinking about different workstations like that. You can really help with your ergonomy of your factory. If you're taking away some of those hardware pre-location from the assembly tables from your employees, you're avoiding a lot of mistakes that way. So it could be something to keep in mind, even though you would be a much smaller fabricator. And the other way you can use one of those fab center would be for your assembly of your mullion. So you could, instead of using an end mill and a copy router, you could be using one of those, putting the bar in, cutting both ends with a cutter stack, and at the same time going in there, doing your lock, doing pre-location of your locks and everything. So there's a lot that can be done on those workstation for I would say much smaller fabricator. If you're looking more at the other side of the screen, then that would be saw with integrated machining center. Those saws are really for the idea behind it is really to have only one workstation, so one employee loading and the other another employee unloading. Those saws are now capable of working at the same flow as high-speed welder. So if you're looking at welding 400 squares, plus or minus 400 squares, you're going to be now able to cut those 400 squares and fabricate them as well at the same speed. So there's been a lot of advance in that technology as in the last few years. When the high-speed welders first came out, we were seeing a lack of cutting capacity versus welding capacity. So even some places they had to get two different saws to be able to feed only one welder if you're thinking high-speed welders. So now just keep in mind that those technologies are out there. You're going to be looking at also what we now call high-speed saws. So thinking about high-speed saws, you do not have to have fab on those. You could also be only cutting. So why would you go only cutting? Is that if you do have a line, pass-through line behind your saw that does all the fab on it, you do not have to do any prefab. So you would be looking at a high-speed saw. So 2 different types of saw where you're going to be having, you're going to be cutting either 1 bar at a time. which is going to bring you to your goal of 400 squares on a shift. Or if you're cutting 2 bars at a time, you're going to be able to actually feed 2 welders or 1 double stack welder for somewhere around 800 squares in 1 8-hour shift. So as I said, there's been a lot of advancement in those saws technology. So just keep an eye on those if saw is your bottleneck at this point. If I'm making my way down the factory, if you're looking at welders, first thing to have in mind, high-speed welders. If you do not have one at this point while you're working with a conventional welder or a 2-point welder, the biggest advantage behind high-speed welders would be obviously capacity, as you're working at just about twice as fast as a conventional welder. High precision, where am I going with that? So if you're thinking about a 1000 millimeters or 1 meter frame or sash, you're going to be cutting it a little bit longer, so to 1006 millimeters, burning 3 millimeters on each side, and then you're going to have your 1000 by 1000 at the end. But for all the good reasons, you could be having problems with your saw, you're cutting too high or too low. Well, high-speed welders do have servo motors in them now that they are actually measuring all the parts that are coming into your welder. So let's say for any reason you would have a 1008 part, the welder is going to know that the part is too long, and it's going to burn off the extra millimeters on each side to end up with your 1000 measure at the end. So it's really helping when you're going to be down your assembly lines, where you're going to be integrating your sash into your frame or the glass into your sash. If you do have those exact measurements every single time, it's going to make your life a lot easier. There's also possibilities of data transfer. So if you're using the same data that the welder is taking at measuring parts, it's going to be measuring the final product that comes out of it as well. So thinking that you could be sending some live information to, let's say, your glaze stop cutter, you could be sending a live cutting list to it, so you would know exactly what size you would have to cut your glaze stops measured on the window that you're assembling. So again, if I'm using that 1000 millimeters example, well, your glass top is going to have to be, let's say, 990, but if the window at the end is really 999, well, the welder is going to send the information to that saw, making sure that the glass top is shorter as well, so it fits right in. You could be using those data transfer as well if you're building, let's say, hybrid windows. If you're doing some wood extensions, any type of measurements that you're going to be taking on the window, normally you could be sending that information directly to your working tables as a cut list or just a list that you want your employees to have. So it's all information that exists. So it's kind of the entering the 4.0 industry world. You're just going to use that data everywhere in your factory, making a better window and helping your employees working faster as well. Another thing that you can do on the welder now, you could have a drill that's been installed between 2 heads to do your mullion post on your frame. So the 3-head drill that only applies to casement frames. But if you do have a welder that's dedicated to casement frames, this could be a good add-on as you're positioning your mullion as the window is assembled and being held at a square inside the welder, so you know that the precision is going to be 100% at that point. You could have also, if you have a 3 light, the same system could be working, making 2 different sets of holes on each side. Just keep in mind that if you're putting this hardware between the 2 heads, you're making your minimum weld a little bit bigger. So if you're going to be using the same welder for frame and sash, I would not recommend having that installed on a welder. If now we're talking about different types of welder, if you build a hybrid window or you're using laminated PVC, there is a lot of new technologies around the seamless welders that are out there. It's not necessarily a technology that has been well adapted to the North American window just yet, as the walls of our windows are much thinner than what we see in Europe. But I have seen those work with hybrid windows and laminated windows. They work very well, but at the same time, it's a long cycle. So thinking about using the seamless welders on your regular window, white window factory, I would not recommend, as you're losing a lot of time on the manufacturing. So if you're thinking about cycles, you're going to be on the high-speed welders, you're going to be somewhere around 1 minute per cycle. And on seamless welders that I've seen throughout different factories, you're going to be more around 4 minute cycle. So you're thinking that your factory output would be cut by 4. So it would not be an advantage to do so. And a good welder, a good corner cleaner these days is going to be giving you the same quality than a seamless welder. That's up to my knowledge and the way I think, but just keep in mind that those products do exist, that are out there. There's just a matter of finding the right solution for the different profiles you have. The other thing that you would have to keep in mind is that the tool change is much longer on one of those seamless welders than on our regular welders. So if you, just like most of North American fabricator, have 20, 30, 40 different profiles passing on the same equipment, just think that you're going to have to be down a lot of times doing tool change-ups. So this is where I would focus my mind when you're looking at those equipment. Next step, if you're working on a automated line, you're going to be looking at either a cooling station, or some companies do use this time as a machining center. So there's possibilities of adding pre-location of hardware on the resting area. So if you're looking at casement sash, you're going to be looking at positioning keepers and snubbers. If you're looking at casement frames, you're going to be, or hung and slider frames, you're going to be looking at pre-drilling mullions as well. So like I said, you could be doing it on the welder, but you could also be doing it on the resting table. It's a matter of precision. It's a matter of gaining some speed down the line. You don't have to do it on the saw. You don't have to do it down the line by an employee with a gauge. So there's you're thinking plant ergonomy and really accuracy at that point. If you're looking at, I have seen some projects for slider sashes. You could do like pre-positioning of the locks, handles, and things like that on that same station. So there's a lot of things that could be added to one of those. If you're building European style windows, the hinges location could be done on one of those machines as well. Next step, you're going to be going obviously to your corner cleaners. So if I'm looking at standalone production, there's a lot of questioning that goes around, should I go for a one head corner cleaner or twin head corner cleaner? The first misconception that people have is that thinking that they're going to go with a twin head is going to be working twice as fast. But for most fabricators, twin heads are 2-axis corner cleaners instead of a single head corner cleaner is going to be a 4-axis. So this means that the 4-axis is going to be cleaning the top and bottom of the part simultaneously. And if you're looking at a twin head corner cleaner with 2 axes, that means you're going to be cleaning top and then bottom. So you're going to be looking at a longer cycle. The advantage that you're going to have towards twin head there is going to be that you can now have some manufacturing done on those corner cleaners. So if you're dedicating a corner cleaner to slider slash hung and slider slash, you're going to be able to do pivots location. You're going to be doing a tilt latch routing, night latch. Those are things that can be added to a twin head corner cleaner, but not to a single head corner cleaner. If you're dedicating one of those cleaners to casement as well, you're going to be able to do rails, hinges, operator arm rails. I'm sorry, I said it. You're going to be able to do some manufacturing on those corner cleaner as well, which is not going to be possible on a single head corner cleaner. But if you're only looking at doing the clean, just keep in mind that either a 1-head corner cleaner or a twin head corner cleaner is going to be giving you an output of somewhere around 225 to 250 squares in one day, depending on what type of windows you're producing on those corner cleaners. Then if you're looking at a pass-through line, you're going to be looking at pass-through corner cleaners. Biggest advantage of a pass-through corner cleaner obviously is going to be speed. You're working at the same speed rate than high-speed welders, so you're going to be looking at somewhere around a minute cycle for all 4 corners. And you're going to be able to integrate a lot of manufacturing at the same time. So you would not have to be choosing between casement sash or hung and slider sashes. You could be prefabricating both of those on the same line. So no dedication to a line is mandatory at that point. And a lot more precise than all other corner cleaners, as you're going to be measuring the part that comes down in the machine at the same time before you start cleaning it. So if I'm taking, again, my example of 1000 by 1000 square, any good reason your welder is off, the part goes into your corner cleaner and it should be 1000, but it's 999. Well, the corner cleaner is going to adjust itself to the right measurements and start its cleaning. So you're not going to have a clean that's going to be off of the corner instead, if you're only giving the information to the machine that it would be a 1000 square. So those are things to, again, keep in mind. Ergonomy, flexibility, and the speed of pass-through line is really going to be helping down the line of your factory. So a lot of fabricator, a lot of machinery guys such as us at JSA are usually stopping at that point where after the corner cleaner, it's kind of left to the customer to do the rest of his factory. There's a lot of things that exist. There's a lot of technologies that exist that people have in mind that only European style window can be taken care of at that point. But that's not true. We have adapted those systems to the North American style window. So easiest way to start helping your production, assisted unloading. So you're thinking that you're not going to have one employee unloading the corner cleaner table. For just one example, you could have a table that lifts the window and puts it into racks. So if you're thinking that you have a high-speed welder, you have 400 squares coming out of the corner cleaner, you're going to have one employee that every minute has to take away one square. So if he doesn't take the window off the line, the whole line is going to be stopped. So if you're putting a system in place that automatically unloads it, it's going to be much easier. So you're cutting down one employee at that point. You're going to be loading racks, but you could also be creating a whole chain after the corner cleaner, where the exit table would be dragging the material to assembly tables, where workers would be waiting on the next part to come in front of them and do their work. So there's a lot of technologies that exist also on tables to assist screwings and things like that. So just keep in mind that those workflow technologies are not just there for the European style window. Obviously, if you're building one of those tilt and turn window, there's something that makes it easier on you, as the hardware is holding by itself. So there's a little bit further that you can push that technology, but it's not only dedicated to this type of window as well. IG sorting system. IG sorting system, I have seen a lot of those systems in Europe where basically the workers are assembling the sash, and as they scan the part that they have in front of them, the system is bringing to them the next IG unit that they need to assemble in their window. So no confusion at looking into the racks at where the next IG is. You're gonna have an inspection that's being done at the beginning of the day as you're receiving all the IGs as well. So you're avoiding a lot of mistakes, a lot of downtimes, a lot of employees looking for their material as well. So I do have a layout that I'm going to be showing you right here. Sorry. Okay, so this layout here is quite simple. That's showing you how you can automate a factory. This one example here, it's a company that builds somewhere around 100 windows a day. So not a huge factory, but as you can see, it's very low in employees. So if you're looking at the top of the screen, you're going to have one employee loading the welder, unloading to a single head corner cleaner with turning station. And if you're thinking that a frame is on it at this point, what the frame is going to do is it's going to be automatically unloaded by the buffer that's on the left of the screen. Then it's going to make its way to the tables that are in the middle of the screen. Employees are going to be assembling the frame, putting it back to the buffer. Buffer is going to bring the frame all the way down on the screen to the vertical table there. Then a sash is going to be coming out of the welder and going directly on the last assembly table at the bottom of the screen. Employee there is going to be doing his assembly on the sash. Sash is going to be automatically unloaded to a magazine of different sashes. So the last employee that you see at the bottom of the screen there, he receives the frame, turns around. After he scans the frame that's in front of him, there's going to be light lighting up on the floor, telling him exactly which sashes are going for that frame. And at the same time as he installs the sashes into the frame, the last machine you're going to see on the right side is a glass sorting system. This is going to be bringing the next IGs that are going into those sashes. So you can think that this employee that's doing the final assembly of the window is only working somewhere around a 10 feet by 10 feet area, and he's just receiving the material instead of looking for it. So there's a big gain in time, and you can add lifting systems to those. Like you could have an operating arm to lift the glasses and help the employees. There's a lot of things that can be done to improve all the workstations. So the biggest challenge we're gonna have with those would be all the different sizes of profiles that we have to go to work with, where the typical European window, the frame and sashes are not so far apart as size. So it's going to be easier for them to create those systems, but those systems can also be adapted to the North American window as well. Next thing I wanted to talk to you guys about is automated paint chambers. I did have a webinar dedicated to those, so I'm not going to be doing the whole 9 yards around that, but just keep in mind that there is technologies out there to be working with either squares or bars. This one layout on the screen right now is done for bars. The reason why I put this one is that I know that the Western fabricator, if I'm thinking about Toronto to Vancouver, is painting more bars than boxes, as Quebec is more painting boxes instead. But keep in mind that this technology can be adapted to either boxes or bar. You do have to do a preparation on the bars or the boxes. You have to take the areas you don't want to be painted. But this is going to be a system that's going to be painting with a robot. So a lot of gaining time there. The employees don't have to be trained to do painting, where if you only have a carousel system with one employee, you would have to someone that knows paint to be doing the job. Now you're looking at just a general employee that's just capable of loading and unloading the line. So much easier job, much easier training that can be done. If you're pushing the bar painting a little bit further, there is technologies out there that allows you not to mask, use tapes to paint the bars. But the problem I've seen with those systems is usually there's not a lot of automation behind it. It's usually one bar at a time, and the employees have to be working with the wet paint bars and loading them to racks. But after doing some research, I did find some companies out there that are offering some systems that are going to be working with the automating those process. So if you're looking at your screen right now, you're going to have on the left, you're going to be loading bars. The machine is going to be painting and using some systems to block the paint from going on the faces you don't want to be painted. And it's going to be unloading to resting area, so that's going to be automated. So the employees at the end are really unloading parts that are dry instead of working with wet paint. So there is process out there that exists that you can be improving your factory painting, even though if you're looking at the painting bars. There is also technologies out there that exist to do a better weld with painted bars when you're not painting boxes to avoid doing touch-ups. So those are all things that we could be addressing together if you want to give me a call after this presentation. So I'm inviting you guys to take a look at the different webinars we did throughout the year. We will be doing more webinars throughout so we're doing one every month, 1 month in French, 1 month in English, and we're going through different subjects in much more details. So I'm inviting you to check out our YouTube channel for the ones that have been done, and stay tuned for the next one coming up. And once again, I want to thank Fenestration Canada for the invitation to participate in this year's Windoor.